Jai Shri Krishna friends. Last time in Tautomerism we can discuss about some examples, some content points, important points or conditions to show the Tautomerism in last lecture. Now we can take some examples of tautomers, or we can think further. Last time we can think about the tautomerism, which type of compound shows the tautomerism, what is the condition and what is the characteristic. The main condition to show the tautomerism is that if any compound satisfies XYZ condition, you know that what is XYZ. X is any atom which can have hydrogen. X does not X should not be hydrogen, but X should contain hydrogen. Y can be any atom, and Z is atoms like carbon, oxygen, nitrogen, sulfur, in short cones. And then we can we can make the tautomers with the help of conversions of hydrogen. Like hydrogen is converted to position number 1, 2, 3, and double bond is transferred to 2, 3 to 1, 2. Clear? Now we can take some examples of tautomerism. Suppose if we can have compound like that, benzene ring, CH2, C double bond O, H, and anyone can say that this type of compound shows the tautomerism, then we can think about the conditions. Z, Y, X, according to our theory, double bond is in between Y and Z, therefore it is X. Here we cannot take X because X should not be hydrogen. X hydrogen no hoई सके. હાઇડ્રોજન સિવાયનો કોઈ પણ એવો એટમ કે જેની આગળ હાઇડ્રોજન હોય. યસ, કન્ડિશન ઇઝ સેટિસ્ફાઈડ. X should have hydrogen. X should have hydrogen, and double bond is between Y and Z, and Z atom is from cones. Z atom is from cones. Then we can draw the another form. Yes, it is keto form. It is keto form. We can draw the enol form, benzene ring, CH double bond COH H, because we can transfer hydrogen from first position to third position, and we can transfer double bond in between 2, 3 to 1, 2, and this is the enol form of this compound. This type of compound or this compound shows the tautomerism. Next one, in some books we can see that in last lecture, in some books condition is like that, the compound which should have alpha hydrogen gives the tautomerism or whatever, but this is not necessary. We can explain in last lecture. Suppose if we can have the compound like that, CH3 CH double bond N OH O minus, and anyone can says that this type of compound shows the tautomerism, then alpha hydrogen concept does not explain properly the compound gives tautomers or not. Alpha hydrogen no concept હશે એ properly આપણને આ નહીં explain કરી શકે કે alpha ટૂંકમાં tautomers show કરશે કે નહીં. Therefore we can think about our condition X, Y, Z, double bond in between carbon and nitrogen. We can give Z, Y and X here because it can have hydrogen. આપણે અહીંયા X નહીં આપી શકીએ. Next, we can say that it shows the tautomerism because the condition is satisfied. Z is cons, means carbon, and X should have hydrogen, therefore you can say that it can shows the tautomerism. Yes, this type of compound does not explain with the help of alpha hydrogen, therefore you can apply simple X, Y, Z. Next, CH3 CH2 and positive charge, double bond O and O minus. Clear? What is the form? Hydrogen is transformed from 1 to 3. Hydrogen is transformed from 1 to 3. X ને આપણે 1 આપશું, Y ને 2 આપશું અને Z ને 3 આપશું, and double bond is transformed from position number 2, 3 to 1, 2. Clear? So this compound also shows the tautomerism. Next example, suppose if we can have compound like that, and we can give Z, Y, અહીંયા તો આપણે X નહીં આપી શકીએ because X should not be hydrogen, therefore we can give X here. Now we can check the possibility. This carbon also satisfy 1, 2, 3 and 4 valencies already. This carbon satisfies 4 valency 1, 2, 3, 4 already. Therefore, X means this carbon does not contain hydrogen atom. Therefore, we can say that this compound does not show the tautomerism. This compound does not show the tautomerism because we can say that X does not have or should not have alpha hydrogen, hydrogen, or we can say that it cannot have alpha hydrogen atom. So therefore, it is nothing but benzaldehyde. Benzaldehyde does not show the tautomerism. Next example is like that. This example also does not explain with the help of alpha hydrogen, friends. We can explain with the help of X, Y, Z. Here we can give Z, Y, X. 1, 2, 3. Our all conditions are satisfied. Therefore, we can form the keto form. How we can form the keto form? Hydrogen transfer from 1 to 3. હાઇડ્રોજન 1 થી 3 ઉપર લઈ જવાનો. ડબલ બોન્ડ જે પેલા 2 અને 3 વચ્ચે હશે એને આપણે 1 અને 2 વચ્ચે લઈ જવાનો. Therefore, this is the keto form. We can say that this compound shows the tautomerism, and this tautomerism is keto-enol tautomerism. Next one, suppose if we can have the compound like that, if we can have the compound like that, we can check it shows or not Z, Y. Now the question is that which carbon we can have designed as a X. આપણે X તરીકે કયા કાર્બનને લેશું? તો અહીંયા તો આપણે X ન લઈ શકીએ because this carbon have already satisfied 4 valency 1, 2, 3 and 4, and we can take or we can label this carbon as a X because it can have hydrogen. Therefore, it shows the tautomerism. આ સાઇડથી આ કમ્પાઉન્ડ ટોટોમેરિઝમ શો નહીં કરે because આ કાર્બનની 4 વેલેન્સી ઓલરેડી કમ્પ્લીટ છે. But this carbon have alpha hydrogen, therefore we can take as a X, and this compound shows the tautomerism. Therefore, very simple. 1, 2, 3. A double bond is transformed from 2, 3 to 1, 2, and hydrogen is transformed from 1 to 3. Clear? Then this type of compound shows the keto-enol tautomerism. Next compound we can have is like that. Here we can label as Z, Y, X or X. We check both possibility. Now the question is that X atom have a hydrogen or not? 1, 2, 3, 4. 4 valencies of this carbon already satisfied. Therefore, it does not have hydrogen atom. 1, 2, 3, 4. 4 valencies of this carbon is also satisfied. Therefore, this carbon and this carbon does not contain hydrogen atom, or we can say that this compound does not have alpha hydrogen. Therefore, tautomerism is not shown by this. Tautomerism is not shown by this compound. Next compound is like that. Suppose benzene ring, cyclohexane ring, double bond and OH. We can take Z, Y, X because double bond is there. We can take YZ. 1, 2, 3. If we can check our conditions, therefore X should have hydrogen. Yes, it is there. Therefore, this compound shows the tautomerism, and the tautomerism, and this is enol form, and this is keto form. Double bond is transformed from 2 to 3. 2, 3 to 1, 2, and hydrogen is transformed from 1 to 3. Here hydrogen, but we cannot write here because લખો કે ન લખો કોઈ ફરક પડશે નહીં. Next compound is like that. CH3, C double bond O, CH2, C double bond O, C double bond O, and CH3. Now we can check the condition. We can write here Z, Y, X or X. We can write X both sides because both carbon have hydrogen atom. We can write here Z, Y, X or X. Therefore, we can say that all conditions for the tautomerism is satisfied. This compound shows the tautomerism. Question is that from here, or from here? We can check in next lectures. Yes, this compound shows the tautomerism from 3 possibilities. અહીંયાથી હાઇડ્રોજન શિફ્ટ થાય તો પણ એ tautomerism શો કરી શકે, અહીંયાથી હાઇડ્રોજન શિફ્ટ થાય તો પણ એ tautomerism શો કરી શકે, અહીંયાથી હાઇડ્રોજન શિફ્ટ થાય તો પણ એ tautomerism શો કરી શકે. એમાં કયો tautomer બનશે, કેટલો સ્ટેબલ હશે, કેટલા અમાઉન્ટમાં બનશે, એ આપણે નેક્સ્ટ લેક્ચરની અંદર ડિસ્કસ કરશું. તો so friends, this is the some examples of compound which can shows or does not shows the tautomers. Here we can have a specific examples like that. 4-member cyclic ring, double bond O, double bond O, and anyone can says that check it, the compound shows the tautomerism or not. Therefore we can label the compounds as X, Y and Z. Here Z, here Y, here we can write X, here we can also write X. But the question is that in cyclic compounds, which carbon is favorable to select as a X? Therefore it is a hint. Friends, મિત્રો, generally X તરીકે તમે એવા કાર્બનને સિલેક્ટ કરશો, you can select the carbon as a X which is sp3 hybridized in the ring, which is sp3 hybridized in the ring. એટલે કે જો રિંગની અંદર ક્યાંય sp3 hybridized કાર્બન દેખાય તમને y ની બાજુમાં, તો પહેલાં એને જ સિલેક્ટ કરવો x તરીકે. And if any carbon in ring which can have sp2 hybridization, we cannot consider it as a x. Why? We can explain in this example or in next example. Yes, તો ક્લિયર કે જો કોઈ સાયક્લિક કમ્પાઉન્ડ હોય તો એની અંદર તમે x સિલેક્ટ કરતી વખતે થોડુંક આ ધ્યાન રાખશો કે we can select first x carbon which is sp3. If any carbon which can have sp2 hybridization, we cannot consider it. Why? We can explain. Next. Yes, તો સપોઝ કે અત્યારે sp2 હાઇબ્રિડાઇઝ કાર્બન છે, અત્યારે આપણે આને અત્યારે સિલેક્ટ ન પણ કરીએ, આપણે અત્યારે સિલેક્ટ કરીએ x તરીકે આ કાર્બનને, તો શું હવે આ કમ્પાઉન્ડ tautomerism શો કરશે? યસ, ઇટ ઇઝ કીટો ફોર્મ. આ એનું કીટો ફોર્મ છે. યસ, તો કન્ડિશન તો આપણી ફૂલફિલ થાય છે કે z should be cons and y should be any, y and z double bond, x should have hydrogen. Yes, it can have hydrogen because 2 valencies are complete with the carbon and another 2 valencies are complete with hydrogen. Then what is the answer? This compound shows the tautomerism. According to the condition, we can say that this compound shows the tautomerism, and we can draw the tautomer in all form like that. This double bond as it is. Now we can say that it is 1. Yes, it is hydrogen. It is 2. It is 3. Hydrogen is transformed to 1, 2, 3. અહીંયા એક હજી હાઇડ્રોજન બચેલો હશે પણ આપણે એને રાઇટ કરતા નથી જનરલી. આ બનશે OH. This forms double bond like that because double bond is transformed to 2, 3 to 1, 2. And therefore we can check the characteristic of this compound. We can draw the enol form. Therefore we can say that, or therefore we can think that this compound does not form. The content of this enolic compound is 0%. 0% means that this compound does not form. Yes, conditions are satisfied, but this compound does not form because this compound is anti-aromatic in nature. Because this compound is anti-aromatic in nature, and generally anti-aromatic compound is a most unstable compound. Generally anti-aromatic compound is a most unstable compound. Therefore we can say that if condition is satisfied, therefore also the compound does not form because it is a anti-aromatic, and anti-aromatic is a most unstable compound. It is not forms in the reaction generally if anyone condition. Generally એન્ટી કમ્પાઉન્ડ્સ બનવાનું ફેવર નહીં થાય કોઈ પણ કન્ડિશનની અંદર, કોઈ પણ રિએક્શનની અંદર. એટલે કે જો પ્રોડક્ટ તરીકે ક્યાંય એન્ટી એરોમેટિક કમ્પાઉન્ડ્સ આવતો હોય તો એ પ્રોડક્ટ ફોર્મ્સ નહીં થાય. Then the question is that you can ask me or anyone, if conditions of alpha hydrogen or XYZ is satisfied, then 100% this compound shows the tautomerism. Then I can say that, or we can say that answer is no. We cannot properly say that if XYZ or alpha hydrogen condition satisfies, then the compound shows the tautomerism. We can think about the form or characteristic of the tautomers. જે tautomers બનશે આપણે એની characteristic ચેક કરવી પડશે ને પછી આપણે કહી શકશું કે એ tautomers બની શકશે કે નહીં બની શકે. Means that જો આપણે કેમિસ્ટ્રીને આટલી લઈએ તો કેમિસ્ટ્રીમાં જનરલી તો કેમિસ્ટ્રી આટલી જ છે. આટલી કેમિસ્ટ્રીની અંદર તો એક્સેપ્શન છે કે જે આપણે યાદ રાખવા પડશે આવા એક્સેપ્શન, or we can remember it, or we can try to explain, or now we can try to explain what is anti-aromatic, because question is that the compound is aromatic, but how we can detect the compound is anti-aromatic or aromatic? Yes, the compounds in organic chemistry are generally three types in aromatic due to the aromaticity: aromatic compound, anti-aromatic compound, and non-aromatic compound. Then the question is that which type of compound is aromatic? We can explain, or we can study in this lecture. But if anyone can say that, what is the problem to take this carbon as a X? What is the problem to take this carbon as a X? Problem is that if you can take this carbon as a X, then the formed tautomer is like that. Then the formed tautomer is like that. And this compound is a very unstable. And therefore this compound also does not consider or not form. Therefore you can say that if you can take X is this carbon or this carbon, tautomers does not form. Anyone can say that why this compound does not form? Generally we can remember that in cyclic compound, cumulative double bonds are very unstable. Cumulative double bonds means in cyclic compound is if double bonds are present in bi to bi or same carbon atom, if same carbon contain two double bonds in cyclic ring, this compound is a very unstable. Why? We can explain. This carbon have now hybridization is sp. This carbon have now hybridization is sp. And according to the theory, if any atom undergoes sp hybridization, the angle or bond angle of this central atom is nearly 180 degree. Is nearly 180 degree. Means that this carbon undergoes sp hybridization, then the angle of that carbon is 180 degree. मतलब कि आ कार्बन sp हाइब्रिडाइजेशन अंडरगो करे तो એનો બોન્ડ એંગલ 180 હોવો જોઈએ. જનરલી અહીંયા આપણને દેખાય ફક્ત કેટલો તો કે 90. મીન્સ દેટ જે એંગલ 180 હોવો જોઈએ એના બદલે એ એંગલ આપણને ફક્ત 90 જેટલો જોવા મળે. મતલબ કે રિંગની અંદર મોર એન્ડ મોર સ્ટ્રેસ જનરેટ થાય છે. એટલું બધું સ્ટ્રેસ જનરેટ થાય કે આ બોન્ડ આવી રીતના ખુલવાનો પ્રયત્ન કરશે, બિકોઝ ધ એંગલ ઇઝ ફેવરેબલ 180 ઇન એસપી. તો આ એંગલ આવી રીતના આમ ખુલવાનો પ્રયત્ન કરશે જેથી કરીને રિંગ ડિસ્ટ્રોય થઈ જશે and the compound does not exist. Concept clear? If you can take X as this carbon or this carbon, if you can take X from this carbon, then the tautomer form is anti-aromatic, which is not exist. And if you can take X as this compound this carbon, then the compound form is a very unstable due to the cumulative double bonds. Therefore we can say that yes, ફરીથી એક્સપ્લેન કરું કે આ ડબલ બોન્ડ બાજુ બાજુમાં રિંગમાં કેમ સ્ટેબલ નથી અત્યારે? એટલા માટે સ્ટેબલ નથી કે એનું હાઇબ્રિડાઇઝેશન એસપી છે. એસપી હાઇબ્રિડાઇઝેશનની અંદર બોન્ડ એંગલ 180 ડિગ્રી હોય, જે 180 ડિગ્રી અત્યારે ખરેખર છે નહીં, 90 જ થાય. જો આવી રિંગ તમે ટૂંકમાં સિલેક્ટ કરો તો જ્યાં 90નો એંગલ છે એ 180 જવાનો પ્રયત્ન કરશે એટલે રિંગ ડિસ્ટ્રોય થશે અને કમ્પાઉન્ડ આવી રીતના બની શકશે નહીં. નેક્સ્ટ વી કેન એક્સપ્લેન the conditions for the aromatic, anti-aromatic and non-aromatic compounds. Therefore you can easily check that the formed compound is anti-aromatic or aromatic or whatever. Now we can think about which type of compound is aromatic, which type of compound is anti-aromatic, or which type of compound is a non-aromatic. First of all we can think about aromatic compounds. First of all we can think about aromatic compounds. Which type of compound is says to be aromatic compound, then conditions and examples we can check it. First of all we can say that if any compound is an aromatic compound, then it is most stable. Then it is most stable. જો કોઈ compound aromatic બનશે તો એ maximum stable હશે. And now we can think about what is the conditions to become aromatic. First three condition is that compound should be cyclic, compound should be planar, and compound should be conjugated. First three condition is like that: compound should be cyclic, planar and conjugated. Compound should be cyclic, planar and conjugated. If you can think about the benzene ring we can check the conditions. First condition is cyclic. Yes, benzene ring is a cyclic. Second condition is that compound is a planar. Yes, benzene ring is a planar. The question is that how we can detect the compound is a planar. In most of case we can detect with the help of hybridization, but in some exceptions we can remember it. થોડાક એવા એક્સેપ્શન ની અંદર આપણે યાદ રાખવું પડશે કે કમ્પાઉન્ડ પ્લેનર હશે કે નહીં હોય, બટ મોસ્ટ ઓફ કેસની અંદર એ રિંગની અંદર આવેલા કાર્બનના હાઇબ્રિડાઇઝેશનથી આપણને ખબર પડી જાય કે પ્લેનર હશે કે નહીં. ઇફ all carbons are sp2 hybridized in ring, then the compound should be planar. If all carbons are sp2 hybridized in the ring, then the compound should be planar. sp2 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 and sp2, we can say that benzene ring is a planar. All atoms are present in a one plane: carbon 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 carbon, hydrogen 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 hydrogen, like that. And now we can think about this type of compound. Suppose we can have compound like that. What is this? Cyclohexene or cyclohex 1-in. Cyclohexene or cyclohex 1-in. This carbon sp2 hybridized, it is also sp2. Now we can think about these 4 carbons, then the hybridization of these 4 carbons are sp3. Anyone can ask how we can detect the hybridization of carbon? It is very simple. If carbon is bonded with 4 sigma bonds, hybridization is sp3. If carbon is bonded with 3 sigma, one is pi or whatever, then it is sp2 hybridized. If carbon is bonded with 2 sigma bond, then the hybridization is sp. And the concept is that if hybridization is sp3, then bond angle is nearly 109 degree, sp2 120 degree, sp 180 degree, which is the information. This carbon have 1 2 3 4 sigma, 1 2 3 4 sigma. અહીંયા બે હાઇડ્રોજન હશે જે આપણે જોઈ શકતા નથી પણ એ હશે 4 hydrogen. Therefore you can say that 1 2 3 and 4 carbons are sp2 hybridized. And you knows that, friends, if any atom undergoes the sp3 hybridization, then the geometry is tetrahedral, and tetrahedral geometry does not have planar. Therefore you can say that this is not a planar compound. We cannot think aromaticity in this compound. First priority is this cyclic, second priority is planar, and third priority which we can check is conjugation. What is conjugation? Conjugation means that in any compound, double bond, single bond, double bond, single bond, double bond, single bond, double bond, single bond, double bond, એવી રીતના જો bonds આવેલા હોય તો એને conjugated system કહેવાય. Therefore this type of system is known as conjugated system. Or in any compound, lone pair, sigma bond, double bond, single bond, lone pair, means that you can consider a lone pair as a double bond. You can consider lone pair as a double bond. ફરીથી અહીંયા single bond હોય, ફરીથી double bond હોય, single bond હોય, double bond હોય, single bond હોય, lone pair હોય. તો આવી સિસ્ટમને તમે conjugated system કહી શકો. If you can think about benzene, double single double single double single, double single double single double single, we can say that benzene ring is a conjugated. We can say that benzene ring is a conjugated system. Now if 3 and 3 conditions, cyclic, planar and conjugated, are satisfied, therefore you can think about the Huckel's rule. If compound satisfies the Huckel's rule, then compounds becomes aromatic. And the Huckel's rule for the aromatic compound is that 4n plus 2 pi delocalized electron. 4n plus 2 pi delocalized electron. Delocalized electron means that the electron which should not be stable at a certain or particular condition in the compound. Suppose કે જો આ pi bond ની અંદર હશે તો electron, this pi bond contain electron. If these electrons are stable is in this condition, therefore you can say that this compound or this compound or electron should be ડીલોકલાઇઝ. જો ઇલેક્ટ્રોન અહીંયા ને અહીંયા જ સ્ટેબલ હશે, એ પોતાનું સ્થાન છોડી અને સ્થાન બદલતો નહીં હોય, તો આપણે કહી શકશું કે અત્યારે એ લોકલાઇઝ છે. સપોઝ કે આવું ને આવું જ રહેતું હોત, આ ડબલ બોન્ડના ઇલેક્ટ્રોન કે શિફ્ટ ન થઈ શકતા હોત, તો આ ડબલ બોન્ડના ઇલેક્ટ્રોનને આપણે લોકલાઇઝ ઇલેક્ટ્રોન કહી શકત. બટ એવું નથી મિત્રો. ડબલ બોન્ડના ઇલેક્ટ્રોન કન્ટિન્યુઅસ પોતાની પોઝિશન ચેન્જ કરતા રહીએ બેન્ઝીન રિંગની અંદર. એ આપણે જોઈ ગયા, અથવા તો આગળ વાત કરશું એના વિશે થોડીક. તો કહી શકાય કે ઇલેક્ટ્રોન પોતાનું સ્થાન લોકલાઇઝ નથી કરતા, ડીલોકલાઇઝ કરે. ડીલોકલાઇઝનો મતલબ કોઈ લોકલ નથી, એમ એનું સ્થાન બદલાતું રહે. The position of the electron is changes continuously. Therefore, you can say that these electrons and these electrons are delocalized. If delocalized electron follows the 4n plus 2 pi electron rule, which is known as occult rule, then it is aromatic. And we can take n is equal to 0, 1, 2, 3, 4 up to n. If you can put here a 0, જો આપણે 0 લઈએ, 4 pi electron means cyclic planar conjugated હોય અને એની આગળ 2 pi electron delocalize થતા હોય, 2 electron pi electron એવા હોય કે જે delocalize થતા હોય, તો આપણે કહી શકીએ કે compound aromatic હશે. If you can put 1 as a n, 4 1 4 plus 2 6 pi electron, 2 4 2 8 8 plus 2 10, 3 4 3 12 plus 2 14 up to n. If any compound is a cyclic planar conjugated and 2 pi delocalized electrons, 6 pi 10 pi 14 pi 18 pi delocalized electrons, therefore you can say that this compound is aromatic. In benzene ring, 2 electron, 1 pi bond contain a 2 pi electron, 2 4 and 6 pi electron which is delocalized. Therefore you can say that benzene is aromatic, very stable compound. Benzene is a aromatic which is a very stable compound. Clear friends? What is the condition for the aromatic compound? Cyclic planar conjugated, and then it follows the 4n plus 2 pi delocalized electron rule. Therefore you can say that the compound is aromatic. આમાંથી કોઈ પણ એક કન્ડિશન પણ ફૂલફિલ ન થાય. If any one condition from this does not fulfill with any compound, therefore you cannot think about the Hercules rule. It is a non-aromatic compound. જો આ ત્રણમાંથી કોઈ પણ એક પણ રૂલને ફોલો ન કરે, કન્ડિશનને ફોલો ન કરે, તો એ કમ્પાઉન્ડ શું હશે? તો કે કમ્પાઉન્ડ નોન એરોમેટિક હશે. એ કમ્પાઉન્ડ શું હશે? નોન એરોમેટિક. તો પછી આપણે ફોકલ્સ રૂલ વિચારવાની વાત જ નથી. નેક્સ્ટ, we can think about the stability of compounds. Therefore you can say that yes, aromatic, non-aromatic, anti-aromatic we can explain in the further lectures in very deep, but now it is a sufficient information to solve the tautomerism. If we can take the lone pair type conjugation, then it is like that. Phenol, lone pair single double, single double, single double, single, lone pair single double, lone pair single double. We can say that this compound is also a cyclic planar conjugated and 6 pi delocalized electron in a ring. We can say that this is aromatic, which is phenol. Clear? Next, if you can think about the stability, then aromatic compound is a most stable. Therefore then after non-aromatic, and then after anti-aromatic. Anti-aromatic is a very very less stable compound or least stable compound. Most stable is aromatic, then non-aromatic, then anti-aromatic. If anyone can ask what is non-aromatic compound, we can say that the compound which is not aromatic or anti-aromatic is non-aromatic. The compound which is not aromatic or anti-aromatic is non-aromatic. આ બેમાંથી એક પણ નહીં હોય, એ બધા non-aromatic હશે. Clear? All open chain structures are non-aromatic because first condition is that cyclic. Now if we can think about anti-aromatic compound, we can say that it is a most unstable compound or least stable compound. First three conditions are as it is: cyclic, planar, conjugated. Cyclic, planar, conjugated. Now what is conjugation? You can know that single, double, single, double, single, double, or lone pair, single, double, lone pair, whatever. And if these three conditions are satisfied in the compound, suppose if we can have compounds like that, cyclic, yes. Planar, yes, because all carbon have sp2 hybridize. Conjugated, yes, because double, single, conjugated. Now we can calculate the delocalized electron. These electrons are delocalized, not stable. આવી રીતના delocalized થતા હશે. Now we can calculate the number of delocalized electron, therefore it is 4. 2 and 2, 4. Not a 2, not a 6, not a 10, it is 4. Now the another rule, it is also known as Huckel's rule, but the sentence is different. Here 4n plus 2 pi delocalized electron, here only 4n pi delocalized electron. Cyclic, planar, conjugated 4n plus 2 pi નું જો એ પાલન કરે તો એરોમેટિક, સાયક્લિક, પ્લેનર અને કોન્જ્યુગેટેડ તો હોવો જ જોઈએ. જો આમાંથી કોઈ પણ એક પણ શરતનું પાલન ન થાય તો કમ્પાઉન્ડ એન્ટી એરોમેટિક ન હોય, તો એ પછી નોન એરોમેટિક થઈ જાય. ક્લિયર? તો 4n પ્લસ 5 ઇલેક્ટ્રોન ફોલોસ કરે જો આ, તો પછી તમે એને એન્ટી એરોમેટિક કમ્પાઉન્ડ કહી શકો. Now n is a 1, 2, 3, not a 0, because if you can put 0, it is 0, there is no meaning. 1 જો આપણે એપ્લાય કરીએ, if you can apply 1 as a n, therefore it is 4 electron. 2, 8 electron, 3, 12, 4, 14, and next one. Therefore you can say that if any compound is a cyclic, planar, and conjugated, and it can follow the Huckel's rule. Huckel's rule is 4n pi electron delocalized, therefore compound is anti-aromatic. If it follows 4n plus 2 pi electron, then it is aromatic. Only 4n pi electron, that is, therefore it is anti-aromatic. આવી રીતના રિમેમ્બર કરી રાખવાનું, યાદ રાખવાનું કે 4, 6, 10, 14 આવે તો એરોમેટિક, 4, 8, 12, 16 આવે તો એન્ટી એરોમેટિક. જો યાદ ન રાખવું હોય તો આપણે ફોર્મ્યુલા તો છે ટ્રાય કરી લેવાની, n ઇઝ ઇક્વલ ટુ 0, 1, 2, 3 and 1, 2, 3 મૂકીને. અને જો ટૂંકમાં કંડિશન્સ મુજબ જે આવતું હોય એરોમેટિક બનતું હોય તો એરોમેટિક, એન્ટી એરોમેટિક બનતું હોય તો એન્ટી એરોમેટિક. નેક્સ્ટ, and this compound is formed in the previous examples of tautomerism. We can say that it is anti-aromatic. We can say that it is anti-aromatic, which is least stable, and therefore it is not formed. Clear? If any compound does not follow these three conditions, then it is not aromatic or not anti-aromatic. It is a non-aromatic, and the stability order of this compound is like that: aromatic, non-aromatic, and anti-aromatic. Here 4n plus 2 pi delocalized electron, here 4n pi delocalized electron. Delocalized electron means that the electron which should moves from one position to second positions with the help of resonance or whatever. What is resonance we can explain in next lectures. Now we can think about some specific examples regarding to the tautomerism. It is like that. Next example is like that. We can have a compound like that. 6-membered ring, double bond, O. We can check the conditions. We can write here Z, Y, X. 1, 2, 3. X should be hydrogen. Yes, it can have, because hydrogen and hydrogen. Then the tautomers are formed. Is like that. Now we can know that double bond transform to 2, 3, 2, 1, 2, and hydrogen transfer from one position to 3 position. This is its enol form. This is the keto form. This is the enol form, which is aromatic in nature, because this ring is a cyclic, planar, and 1, 2, 3, 4, 5, 6 electrons are delocalized in the system. 6 electrons are delocalized in the system. Therefore, we can say that this is aromatic. This compound is very stable. Therefore, the amount of this enol form is near about 99.8%. It means that this compound shows the tautomerism. Yes, it is in a very less amount in the equilibrium mixture, but this compound is exist in 0.2%. મીન્સ દેટ એવું નથી કે આ કમ્પાઉન્ડ ટોટોમેરિઝમ શો નહીં કરે, શો કરશે જ, પણ મોટા ભાગે એની અંદર વધારે અમાઉન્ટની અંદર કોણ હશે તો કે 99.8% ઇનોલ ફોર્મ હશે, જ્યારે 0.2% ઓનલી કીટો ફોર્મ હશે. પણ કીટો ફોર્મ હશે એ ફાઇનલ, જેથી કરીને આપણે કહી શકીએ કે ધીસ કમ્પાઉન્ડ શોઝ ધ કીટો ઇનોલ ટોટોમેરિઝમ ઓર ટોટોમેરિઝમ. બટ ધીસ કમ્પાઉન્ડ ઇઝ પ્રેઝન્ટ ઇન અ વેરી મોર અમાઉન્ટ due to the aromatic nature of phenol. It is very stable as compared to the keto form. Next example is like that. 6-membered ring, double bond, double bond, double bond. Here 4-membered ring, here double bond, double bond, double bond, O. Now we can write here Z, Y, X. We cannot take X here because it is sp. sp2 hybridized carbon atom. We can say that if any carbon which can have sp3 hybridization in the ring, we can select it first. Therefore we cannot take here a X. Therefore now we can understand that conditions are fulfilled. We can say that tautomerism is so because X should have hydrogen, કારણ કે X આગળ 2 હાઇડ્રોજન હશે અહીંયા હવે. તો if we can write here a 1, 2 and 3, hydrogen is transformed from 1 to 3, double bond is 2, 3 to 1, 2, then the compound is like that. But if you can check the nature of this compound, અહીંયા તો ડબલ બોન્ડ હતો જ, અહીંયા ડબલ બોન્ડ ક્રિએટ થયો. Now if you can check the nature of this compound, therefore it is anti-aromatic. Therefore it is because આ રિંગમાં તો કોઈ ચેન્જ આવ્યો જ નથી, જે ચેન્જ આવ્યો એ આ સાઈડ આવ્યો, તો આપણે એ બાજુ જ કન્સિડર કરશું અત્યારે. તો 2 electron cyclic, yes. Planar, yes. Conjugated, yes, because double, single, double, single, double. How many electrons are delocalized in the system? We can say that 2 and 2, 4, because one bond contains 2 electrons. 4 electron is a delocalized. We can say that if 4 electron is a delocalized, then compound is anti-aromatic. This compound does not exist. Therefore, I can say that this compound does not show the tautomerism. Remember that always, friends. Next, suppose if we can have a compound quinone, 6-membered ring, double bond, double bond, double bond O, double bond O. Compound is a symmetrical. Compound is a symmetrical. You can take Z, Y, X or X here. X આ સાઈડ લ્યો કોઈ ફરક નહીં પડે because compound is a symmetrical. Or તમે અહીંયા Z ને લેબલ કરો, અહીંયા Y લખો, પછી અહીંયા X લખો કે અહીંયા X લખશો તો પણ કોઈ ફરક નહીં પડે. આપણે સરળતા ખાતર અત્યારે Z અહીંયા એસાઇન કર્યો છે, Y and X. Now condition is fulfilled with respect to the XYZ because X should have 1 hydrogen here. 1, 2, 3. 3 satisfied have 1 hydrogen hase. Z should be constant, all are fulfilled. We can make its tautomer is like that because double bond is transformed from 2, 3 to 1, 2. 2, 3 to 1, 2 and hydrogen is transformed from 1 to 3. The compound is like that. If we can think about this tautomer or compound, then double bond and double bond present in the same carbon atom, or we can say that it is a cumulative double bond in the ring. And these types of rings are very, very unstable or less stable due to the strain. We can explain it in a previous example. Now, if we can take the hybridization of this carbon, it is sp. It is sp. If any carbon or any atom undergoes sp hybridization, then the angle between the atoms is 180 degree. Is 180 degree. If you can check here, it is near about 60. It is near about 60. Oh, sorry. It is near about 120. So therefore, you can say that this bond is like that here. It makes like that. Therefore, it is stable. જો 180 નો બોન્ડ હોત આમ તો એ સ્ટેબલ થાત. 180 છે નહીં, જેથી કરીને શું કરશે તો કે રિંગને બ્રેક કરવાનો પ્રયત્ન કરશે, કમ્પાઉન્ડ અનસ્ટેબલ બનશે, એક્ઝિસ્ટ નહીં કરે. મીન્સ આલ્ફા હાઇડ્રોજનની રીતે કન્ડિશન ચેક કરીએ તો પણ ફૂલફિલ થાય છે, XYZની રીતે કન્ડિશન ફૂલફિલ કરીએ તો પણ ચેક થાય છે, પણ ટૂંકમાં કમ્પ્લીટ થાય છે, પણ છતાં a compound tautomers show કરશે નહીં quinone because of the formation of very unstable compound. So we can say that we can check first the condition. If condition is fulfilled, then we can make the tautomer. And tautomer બની ગયા પછી આપણે એવું નહીં કહીએ કે tautomerism શો કરે જ છે, but we can take the we can check the characteristic of the tautomers which is formed. If it is aromatic, then it is very stable. It is anti-aromatic, not formed. Strain compound, not formed. This strain is explained with the help of Bayer strain theory. This strain is explained with the help of Bayer strain theory, but it is clear that the angle should be 180, but here not a 180, it is very less amount, very took my less as compared to 180. Therefore more and more strain in the ring and ring is destroyed. Yes, another question is that if this type of compound is exist or not. So આમાં એવું થાય કે ring destroy થઈ જાય? નહીં મિત્રો, because if we can check the hybridization of any carbon, then it is sp3. If any carbon undergoes the sp3 hybridization, then the bond angle is like 109 degree. 109 degree. And according to this bond, it is near about 109, not a perfect 109, but this type of compound is exist. Here is a very difference because 182 very less. Here not a very less. Therefore you can say that this type of compound is a exist. Clear? Next very specific example is like that. Compound is like that. 6-membered ring, 3-membered ring, double bond O. Double bond O. Now we can check the conditions of x, y, z. We can write here z, here y, here x and x because both have sp3 hybridization. Therefore we can check if hydrogen is transferred from this x atom, here 2 hydrogens, here 1 hydrogens, or hydrogen is transformed from this x atom. First we can remove the hydrogen, or we can transfer the hydrogen from this one. We can say that the tautomer formed is like that because here 1 2 3 hydrogen and 2 3 2 1 2 double bond. The compound is like that, and compound is a very more stable compound as compared to this compound. And if you can think from this x, the compound formed is like that. The compound formed is like that. Now x, y, z, here 1 2 3, double bond is transformed from 2 3 to 1 2, and hydrogen is transformed from 1 to 3. Compound is like that. Now the problem is that here this carbon undergoes now sp2 hybridization. The angle is 120, but actually this angle is now here 60. These all are 60 60 60. આનો એંગલ હોવો જોઈએ 120 according to the 120 according to the sp2 hybridization because of sp2 hybridization, but it is now only and only 60. અત્યારે ફક્ત કેટલો છે 60, જેથી કરીને કહી શકશું કે હાફ છે. મોર સ્ટ્રેન હશે, મતલબ કે કમ્પાઉન્ડ લેસ સ્ટેબલ, ઓછો સ્ટેબલ હશે, but this compound should be formed and exist. Now anyone can say that draw the tautomers of this compound. Therefore we can draw this compound and this compound. And MCQs is like that. એક ક્વેશ્ચનની અંદર આ કમ્પાઉન્ડ આપ્યું અને પછી એમ કહેવામાં આવ્યું કે નીચે ઓપ્શનમાં 4 આવી રીતના ટોટોમર્સ ડ્રો કરેલા હોય, 2 બીજા કોઈ ખોટા ડ્રો કરેલા હોય, રોંગ. એમ કીધું કે ફ્રોમ ધીસ which tautomer of this compound is a more stable. Therefore you can think about the stability. This is a less stable, this is a more stable. Yes, this tautomer is also formed and these tautomers are also formed, but this is in a less amount, this is in a more amount, but both forms are exist. So MCQs is like that. આવો compound આપી દેવામાં આવે અને નીચેના ઓપ્શનમાં આવા બીજા compounds આપી દેવામાં આવે ને કે from this which is a more stable, less stable, what is the order of stability. Therefore you can think about this type of concept. Clear? Today we can complete like that. In next lecture we can think about the further examples of ketoenol tautomerism, and specially we can give the basic information or very important information regarding to the enolic content and percentage of enol content in a ketoenol tautomers. Therefore, we can think in the next lecture, but today like that. Further next time.